This video is for class 7 physics, and we are studying a new chapter called light energy. A new chapter called light energy, right? You people can go to page number 50. It's in page number 50 for my book. So probably you must have studied something about light in class 6. So let us discuss this term light. Okay. So light is a form of energy, right? It is a form of energy. You know what is energy? We just studied in the previous chapter. Capacity to do work. Okay, so light is a form of energy which gives us sensation of sight, right? With the help of which we can see things. The light coming out from your mobile phone is reaching your eyes, and you are being able to see the picture which is appearing in your screen. But if you switch off your phone, a black screen appears. That means though the screen is not emitting any light, so the thing appears black. So in order to see things, that means you have to have light entering in your eyes. Okay, let us go to page number 51. We have come to page number 51 and we are dealing with light. Okay. So we have learned that light is a form of energy which gives us sensation of sight. As you all know, in class 6 we must have studied sensation. Okay, it is there we have 5 sensations. It is the thing in our body, sensation, which is initiated by energy. Like we can hear things because of sound energy, we can see things because of light energy. So there are other various kinds of energies also. We cannot see light, but objects around us can only be seen in the presence of light. For example, suppose you are entering a room. Suppose you are entering a room and you are entering your friend's room, and it is your first time you are entering the room. As you enter the room, suppose the light goes off, then you will be not knowing where the objects are. So what will happen is you might have high chances of colliding or dashing with the objects. But when the light is switched on, or if it comes back, what will happen is the light coming out from the bulb or any other source will strike the object, and then that light will come and hit the eyes, right? Hit the eyes, and when that light strikes the retina of your eye, you are able to see things. Just now you must have observed that the screen went off, it changed black. At that time you are not able to read the thing because there was no light emitted from the screen. So let us go to the next line. We cannot see light, but objects around us can only be seen in the presence of light. The objects around us are not seen in dark, that is, in the absence of light. Objects are seen when light after striking them returns in the same medium and reach our eyes. Light travels in a straight line. This is called rectilinear propagation of light. So light travels in a straight line. Light travels in a straight line. Light travels in a straight line. This is called rectilinear propagation of light. Okay, let me try to explain this. Okay, now we have come to a black screen. There's nothing is emitted from this screen. No light is getting emitted from the screen. That's why it is appearing dark, black. And on this screen, suppose I mark with a line. You can see a green colored arrow, right? That means green color is getting emitted from your screen, and hence you are able to see that green color. So now I was talking about rectilinear propagation of light. That means light travels in a straight line. Suppose you take a pipe, right? Suppose you're taking a pipe. You light a candle here. Suppose you light a candle here. The candle will give light, and you are able to see the light from this end. Suppose this is your eye, you are able to see the light. But suppose what happens is suppose you bend the pipe. Suppose you bend the pipe. Suppose you're bending the pipe in this way. And then you light the candle here. Will you be able to see from here? I don't think so, because the light coming out of the candle gets obstructed by the pipe. So this proves that light travels in a straight line. This proves that light travels in a straight line. This is all about rectilinear propagation of light. This is all about rectilinear propagation of light. So let us go back to the book in page number 51. Okay, we are back to page number 51. The medium through which the light passes easily is called transparent medium. Like we have glass, I think you're done in class 6, like we have glass or you have water. So light can easily pass through it. It does not produce any shadow. So transparent medium generally does not produce any shadow. Light can travel in vacuum. Therefore, we receive light from the sun also, because the earth has atmosphere, but beyond the atmosphere of the earth there's nothing, there's a space, there's a vacuum, right? So light can even travel in vacuum, unlike sound. So every day when we or you comb our hair, we stand in front of a mirror and see our image in it. We can also see our image in the still water of tank or pond, lake, the surface of a polished table, a silver polished utensil, or a shining steel plate. This image is formed when light reflected by you strikes the surface, and after striking it returns so as to reach our eye. This returning of light in the same medium is called the reflection of light. Okay, I would like to explain this. Actually, our chapter is all about reflection of light. I would like to explain this in a very simple manner. Let us consider a mirror. Suppose you are standing in front of a mirror. Right? What happens is you can see your, just want to change the color, slightly bluish. Okay, you can see your image around here in the mirror. Okay, so how does this image is formed? What actually happens? Actually, the light comes out from your face, strikes the mirror, and then it gets reflected back. Okay, so when the light strikes the mirror and when the light is coming back of the mirror, an image is created on the mirror, right? So this bouncing back of light from any surface is known as reflection of light, and this is the topic to be discussed, right, in detail in class 7. So the next topic will be reflection of light, and let us go to the same page, page number 51. We are back to the same page, page number 51, which is reflection of light. Okay, I hope it is visible in on the screen. If it is not visible, so kindly refer your book. So let me zoom a bit. Okay, I think this will work. So reflection of light. If you throw a ball on the ground, you notice that it rebounds, it comes back after striking the ground. Similarly, when the light falls on a shiny surface, as I have drawn on the black screen and so is shown to you, when light falls on a shiny surface such as mirror, it returns back into the same medium after striking the surface. Here medium means, let me change this color, okay, yellow. Here medium means, like we have transparent, opaque and translucent mediums. Okay, suppose you are standing in front of the mirror, what is there in between you and mirror? It should be air, right? So when the light is coming from your face and strikes the mirror, okay, it has to travel through the air, and after striking the mirror it has to come back, and when it comes back it is again traveling in the air, so it is coming back to the same medium after striking the surface. So thus the returning of light in the same medium after striking a surface is called reflection of light. This striking a surface, okay, the first thing, it needs to strike a surface, it needs to return back in the same medium. So these all small things are very important while defining reflection of light. So the returning of light in the same medium after striking a surface is called reflection of light. So when light falls on an object, a part of light is reflected. Why are they saying a part of light? Why not all? Why only a part of light is reflected? Because when it strikes a surface, some amount of light is absorbed by the medium, it is taken by the medium, right? So that means if you throw 100 light energy to a surface, the surface might take 1 or 2 and then give back us 98 or 97 depending upon the medium. If the object is opaque, the remaining part of light is absorbed by the object. That means if the surface is opaque, if the object is opaque, then what happens is most of the light is absorbed, right? If the object is opaque, the remaining part of light is absorbed by the object. But if the object is transparent, the remaining part of light passes through the object. That means suppose you are throwing 100 amount of light on a surface which is opaque, what will happen is it will absorb it, right? Whatever is not reflected, it will absorb it, it will take to itself. But if the same light is striking the transparent object like glass, water, it will absorb some amount of light, but whatever light is remaining, it will let it go through it. That's why it is transparent, so the light will pass through the object. Thus all the objects reflect light, all the objects reflect light. It might be transparent, translucent or opaque, because if the object does not reflect light, we cannot see that object. We can see the glass, right? It will not allow 100% of light to pass through it. If something allows 100% of light passing through it, then we cannot see that object, because no light is getting reflected from that object. In order to see the object, light has to get reflected. So different objects reflect light to a different extent. A highly polished and smooth surface such as plane mirror reflects almost the entire light falling on it, while a transparent object reflects least amount of light. See here they are saying almost the entire, not all, okay, almost the entire light falling on it. So some amount will be absorbed also. So when a transparent object reflects, the least amount of light is getting reflected. When a transparent object, you can see least is getting reflected and most of them is getting passing through it. Okay, the last